Hello, everyone. Uh, Welcome and have a good time in watching our movie, which is a film for supporting lectures of Dr. Engineer Wioleta Barcewicz from Warsaw University of Technology. On that movie, we will create a portal frame which has 3 stories and 3 bays, and it will be only a model creation without a designing uh, and analysis. My name is Adam Machowiak. I am designer, a structural engineer, and exclusive distributor of Consteel in Poland. That how it looks, the static scheme. It has 3 stories, 3 bays. Every story has 380 centimeters. Each bay has 780 centimeters. Every main beam is supported by the lateral beam, a secondary one which is perpendicular to the portal frame, and the supports are pinned. So let's start. We are creating it in the Consteel, structural analysis and design software, mainly for steel. So first of all, we have to load the sections from the library. We need for our frame, in my case, the IPE 450 and 500 sections, so we have to load it. And as well, we need the sections HEA in 260 and HEB 300. So if we close and go into it again, we see all the loaded sections. So firstly, we will create the columns which has the all height of the building, and it will be 11 meters and 40 centimeters, and built from the section HEA 260. So now we are ready to put it into the model. Then we can just copy it 3 times by the distance, which is our span. I've just put the L button and write or type the proper length, and as we can see, nicely copied columns. Now I will change the section for the proper one, HEB 300 in the middle, and if we have the columns, we are ready to put the supports. So it will be that kind of support, and we can put it at one time on the every column. So now we have the supports created for each column, and we are ready to create the main beams. The first one is the upper one, and it is built from IPE 450 section, and now we can draw it like just 3 separate beams. We are ready now to copy it for these 2 rest stories. Now I have the dividing points, which are dividing our bars into 4 uh, segments, but I can change it to divide it for 3 segments. So it will be these 2 rest stories. Now I will copy it, but change for the 1, and every story is copied just like that. Very easy and fast. Okay, now we are ready to change the sections, which will be here. IPE for 500. Okay, and I will put the secondary supports in the Y direction, which will be representing our secondary beams, which are perpendicular to our main frame. And I will put it on the upper flange of our main beam. So we can start creating it. This is the first click, and I have to now click to show to point on which beam it should have been put it. Then again the first and another. Okay, and again the first and another click, and another. Okay, now we can just copy it to the 2 rest beams. It has adjusted automatically to the upper flange of our beams. Okay, so more or less the model is creating. It is a good technique and a good manner to analyze from time to time our model to see whether there are some very big problems or not. If it will start analyzing, it shows that there's no problems in the model. Okay, so now we have the all main members or supports. You can see everything is in. We can start loading our model. Okay, first of all, we have to switch to the tab which is called Loads, and then go into the Load Cases and Load Groups window, and we can now change the name of the load case from just a load case to permanent. Okay, and we will create a new load group which will be a variable. Okay, and we will have 3 cases of the variables, and it will be a new load case, and we will change the color and as well the name for variable 1. Then we can copy it for the next and another, and we'll just very simple change the names, and here as well. It is very good to know where from we can obtain the standard values of factors. So we have to go here into that icon. There will pop up a window where we can choose the category of the variable load. In my case, it will be category E. Then I will apply it. I can see that the values of the factors has been changed. Okay, now we will create another group for the wind. And I will create two new load cases for wind 1 and wind 2. Okay, I have created it in permanent, so it is not a really big case because I can move it just to the proper load group. Okay, so I will delete that one, which is not necessary here, and it was created by accident. So okay, everything is just in order. Now I can choose that this permanent could be very favorable in the combination, and it has left the last one load group for just a snow loads. I can create a new load case. I change the color of it, and there will be only one snow load. Okay, apply. You can see that you can as well change the appropriate factors for the load, for the snow load. I will assume that this is below the sea level, which is in this case below the 1000 meters. Okay, so here we can see the changed factors, and we're clicking apply button and then OK. What has left is to create the combinations and then put the appropriate loads into our model. Okay, this is very simple. We open the load combinations window. We're deleting the predefined row and then going into automatic generation of load combinations. Okay, we're choosing the formula 6.10 AB and creating apply and pushing apply button, and the auto generator has created the all necessary load combination. We pushing the button apply and then closing these load combinations window by the button close. So now we have just to create the appropriate or input the appropriate loads into our model. So first for permanent. In my case, it will be the minus 26.5, but there is no minus sign. Okay, I can copy it by Ctrl+C button. I can paste it as well. And now just put into the every loaded beam, but I have made a small mistake because in this first and second floor I have the different loads, which is 36. It is very easy to change. Just select, and then type the correct value. Okay, so we have the all permanent loads. The next is the load case variable one. And as well, I have different for the roof beams and different for the stories beams. For the roof, I have 6 kilonewtons, and as well I can put it for every beam. Then there will be another one case and another one as well. But I saw that there is two variable 2, so I will change it very easy as well. I can see that now it has changed the name into the variable 3. Okay, I'm coming back to the variable 1, and I'm just changing the line load into the value 30, which is in my case the variable into the first and second story of the building. Okay, then for the variable 2 load case, I'm doing exactly the same. Sorry, I have to select the beam and just put into the model in the proper places on the proper beams, and as well I have made it for the variable 3. Now I jumped to the snow, and I have the snow value in my case, which is 1.42 multiplied by 6, which is 4.32. And as well, now I don't need to go to global projections system, because our beams are horizontal, perfectly horizontal. Just to type 4.32 and 4.32 from the other end of the line load. Okay, so the wind is already done, and the snow is already done, and I can go to the most difficult, which is wind. And in my cases, I've done 2 load cases. In my case, I've done 2 load cases, which are when the wind is blowing from the left to right, and the other when the wind is blowing from the direction which is perpendicular to our portal frame. So we are starting in creating the first case of wind. So for these 2 H columns, it will be 3.24 on the first column. The wind is blowing from that side, and from the second one is 1.62. Okay, and now I have to create the wind on the roof. What I have to do is change the value, and it will be on some part of the roof. There will be a suction, and from the other there will be a pressure, and all will be acting in the Z direction of the global system. Okay, so we have here 528, and as well the value is 528, but on the only some part of the roof. So now I'm typing the L button and the proper length of our wind load. Okay, so we have the first one. Now the second one as well. From that point, the first click, then direction, button L, and the length should be 9,120 millimeters, and it's finished. And that's the zone of the suction of the wind. And what left is the zone of the pressure. In my case, it is the value of 0.9. And again, we have to click the start position of the load and the end position of the load, and it's finished for the first case. Okay, so now I go to the wind 2, and similarly I have on the first column minus in the X direction minus 3.54. It is in the global X direction. Okay, because it's suction, and plus 354 because it's suction on the other column. And for the roof, I have chosen just the pressure because in my opinion it is more, for of course a portal frame, more it is more sorry, I forgot the word. It is the worst case. Okay, so I'm just typing minus 0.9 minus 0.9, and just I will input in the every beam, and this is finished. All the loads are placed into our model. We can look at it, the first variable, second, and the third. We have first wind, which is blowing from the left to the right. We have second wind, which is blowing perpendicularly to our portal frame. And as well, we have the snow, one case of it because it's a flat. So now it is, as I said, a good manner to check whether the model is calculating. Okay, I will go, every combinations are there. I will push the button apply and calculations, and we'll see what's happened. Everything has been calculated. I can see the envelopes here. That's the deformation, but for internal forces, My, you can see that everything is like expected. So that was more or less everything. I hope that you will enjoy to work and to exercise with software Consteel. And thank you for your attention and goodbye.